Yes, class. Is this audible to you people? Khalid, Samaira, Sneha.
Yes, ma'am.
All right. Samaira, where were you? Oh, your exams were going on.
Yes, ma'am. My unit was over.
So now they're over?
Yes, ma'am.
All right. So how did they go?
It was fine, ma'am.
It's fine. On physics, what about physics?
That was also okay.
Okay, good. All right. So, Samaira, now we have reached till potentiometer. In the last class, we had discussed Kirchhoff's law. So now let's start with potentiometer. See, potentiometer is basically, this is a device which is used to measure EMF or potential difference. But it gives you the exact value of whatever is the EMF of the circuit or whatever is the potential difference of the circuit. So basically, it has a principle on which it works on. Principle we'll discuss later. First, let us see the construction of it. Basically, a wire is there. L length, let's say L length is the wire. This wire is known as the potentiometer wire. We call this as a potentiometer wire. And this, let's say this is point A, this is point B. So this is our potentiometer wire. Yes, good evening, Zaid. Where were you? Again, Zaid disappeared.
Ma'am, this is my joining time.
Yes, Zaid.
Ma'am, this is my joining time. 7 o'clock in here.
Okay, no, I was asking you about the last classes. Last two classes, I think you were not there, no, Zaid?
Yes, ma'am.
Okay, so the rest of the construction involves, this is wire that goes through the cell. Cell has a EMF E, which has to be measured by the potentiometer. And then the internal resistance is there in the EMF. An external resistor is also connected along with this wire, and this completes your circuit. So basically, this circuit is known as a potentiometer circuit. If you see the diagrams of potentiometer in your NCERT books, you can see those wires have been drawn broadly. Mainly, in short, you can see this is the construction of the potentiometer wire. Now, how does it measure the exact potential difference, and how does it get us the value of the specific EMF? It has various applications, not only the EMF, it is also used to calculate the internal resistance and different applications that we see. Now, the principle involves what? If a constant current is flowing through a wire of uniform cross section, means the area of cross section is uniform, then whatever is the change in potential, whatever is the decrease in potential across any section, that is proportional to its length. This is the principle of the potentiometer. Whatever is the potential difference across this circuit, means across the cell, EMF, that is directly proportional to the length of the potentiometer wire. So this is how this is used to measure the potential difference. So now the theory portion, how it is actually utilized. In case of theory, you should remember first, small r is the resistance of the potentiometer wire. Potentiometer wire will also be having its resistance, its internal resistance. So let's say small r is the resistance of potentiometer wire. Now, current we have already studied. If you remember terminal potential difference, there are cases when you were studying it. Current was given by how? EMF of the cell divided by the total resistance. If you people are able to recall, we did this. I is equal to EMF divided by the total resistance. So what is the total resistance? First will be the external resistance, means the resistance of the external resistor. Along with it, yes, plus smaller. That is the resistance of the potentiometer wire. This is the current. Voltage across this whole wire AB this wire. This potentiometer wire, AB. I've just named this wire so that it distinguishes the voltage across this wire and the voltage across the whole circuit. So basically, VAB will be what? Current multiplied by the resistance. V is equal to IR. So current will be there for the whole circuit. But resistance, what should we take? Capital R or small r? Yes, capital R or small r? Yes, Hania, where were you? Same, your unit tests were going on.
Yes, ma'am. They just got over yesterday.
Are you both in the same school, Samaira and Hania?
Yes, ma'am.
Okay, all right. See, yes, Khalid, current
Yes,
is
teacher.
I am calculating voltage across the potentiometer wire. So what will be the formula? I into capital R or I into small r?
Capital R.
Why capital R?
No, small r.
Small r, no, resistance of the potentiometer wire. We are calculating VAB is what? VAB is the, let me write it. This is basically the voltage drop across wire AB. So resistance will also be of the potentiometer wire. So this is I multiplied by small r. So put in the value of IVAB will be equal to what if you put it? This is EMF divided by capital R plus small r, which gets multiplied by small r. Now, potential gradient is one more thing that you should keep in mind. This we have already discussed somehow, but it's just that here the definition of small r got changed. Small r is the internal resistance of the potentiometer wire, means the resistance of the wire. And VAB is the potential difference across this wire. Now, one thing that you have to remember is potential gradient. So potential gradient is not a new term for us now. When we were discussing electric potential chapter, there we had seen a relation between electric field and potential. What did we see? Electric field was directly proportional to potential gradient. So gradient, I have told you this a lot of times, that whenever anything gets divided by time, we call it rate of change, like distance, or when we say rate of change of distance, this is called as velocity, because distance is getting divided by time, distance is getting changed by time. When anything changes with respect to position, then you don't call it rate, you call it gradient. The way E is equal to minus dV by dr. dV getting divided by dr means voltage getting divided by length. That you call is as a potential gradient. So here also it will be voltage per unit length. This will be voltage per unit length. So just to make it unique and to remember that this is the potential gradient of the potentiometer wire, we just use the symbol K to show that this is the voltage per unit length across the potentiometer wire. So this can also be utilized. All right, so before moving on to numericals and to see how questions come on potentiometer, firstly, you people note down till theory portion, then we'll see how do questions come from this. You can put the value of VAB from here. If you're asked to calculate the potential gradient, no, so you can put this whole value, E R plus R multiplied by small r and then divided by L. This is also one formula if you put VAB from here. Done with the writing part. Let's see a numerical then. See, this is a question where you have EMF of the cell as 15 volts, resistance is given to you as 5 ohm, 10 meter is the length of the potentiometer wire. Now, resistance of the potentiometer wire is also given to you. So, this is capital R, this is small r, 5, that is given to you. And EMF, this is 15 volts and length is 10 ohm. So basic question is there. You have to first calculate the current in the wire. What was the formula that we had seen? This was the formula of current. I is equal to E plus capital R plus small r. Current is EMF divided by capital R plus small r. Now see, EMF of the cell, this is already given to us. Everything is provided to it. This is a formula based question. EMF is 15 volts, capital R is 5, and internal resistance means the resistance of the potentiometer. This is also given to us as 5. So this becomes 15 divided by 10, which is 1.5 amperes. Now, second part says voltage across potentiometer. So voltage across potentiometer means VAB. VAB, what was the formula? Either you can do this or you can just simply multiply it by small r. See, both the methods are correct. You have already solved current. You have already solved this part. So just multiply it by the resistance of the potentiometer wire. So potentiometer wire resistance is given to you as 5. So yes, who is going to tell? Memuna. What will be the answer for the second part? VAP. How should we solve it? Current multiplied by the resistance of the potentiometer wire. So what is the current? What is the resistance? Memuna.
Current is 1.5.
Yes, and resistance of the potentiometer wire, current is 1.5. Yes, right?
5.
5. See, both the resistance are given to you as 5. The external resistance is also connected as 5 ohm only, and the internal resistance of the potentiometer wire, that is mentioned to you, which is 5 ohm. So this becomes 15 into 5. This is 75. No, so that will be 7.5 volts. Now the third part. Third part says what? Potential gradient. Potential gradient, I have told you. Potential gradient, you can even remember by the definition. Gradient always means anything that gets changed with respect to position, or just divide the quantity by the position. So potential gradient is what? VAB divided by the length. Length of potentiometer wire is given to you, that is 10 meters. So third part is what? K is given to you as VAB divided by capital L. Yes, Hania, can you try? What is VAB? What is L? Yes, Hania,
No, ma'am, I'm a little confused here.
you are confused. Yes, Khalid, your answer is right. See, Hania, voltage across the potentiometer wire. Have we calculated it? VAB. See, have we calculated it?
7.5.
It is 7.5. No, Z, check again. Check your answers. Samaira is right, yes. So see, Hania, this is 7.5. And look at the question. What is the length of the potentiometer wire given? Just look in the figure. Is there any length that you are able to see, Hania?
10 meter.
10 meters. So this is the length of the wire. And what is potential gradient? Potential gradient is potential across the potentiometer wire by the length. So this becomes 0.75. Now clear, Hania?
Yes, ma'am, thank you.
So the SI unit will be volt per meter. Yeah. So this is how you solve. This is a formula based question. One graphical question also we'll see. But before that, just note it down. Yes, sir. Point 7. Let's do a question of graphs now. You have V versus L graph, means potential versus length graph. So B is making an angle of 60 degree and A is making an angle of 30 degree. First, you have to calculate the potential gradient. Second, you have to compare the sensitivity of the potentiometers. The second part I'll discuss, I'll do. First part, at least you people try. Take 2 minutes, it is very easy. The first part calculation is very easy. Just try it. See, if you people remember, I have told you, whenever we take the ratio of two quantities, that gives, obviously, potential gradient is what? Potential gradient will be V by L. Whenever we take take the quotient of two quantities, or whenever we divide two quantities, then we get the slope of the graph. If we take the area, then we get the third quantity. That is a different thing. But if you divide two quantities, then you take the slope of the graph. You get the slope of the graph. So slope of the graph is given by tan theta, which will be equal to V by L, which is actually the potential gradient. So this is a hint for you. Most of you should try to answer this question. Both the potential gradient. Tell me what should be the value of Ka and what should be the value of Kb. Both. Ka and Kb. Just take 2 minutes, write yourself. Slope is tan theta, tangent of the angle that is given, and the ratio gives you K. Khalid, no, check your answers again. Zaid is right. First one is Ka, no? Zaid, Ka and Kb, you have written it, no? Both the answers are right. Others also try. This is a simple question. Even students who were not there in the previous class, you all people can try. 60 degree angle is given, 30 degrees given. Ka, yes, Khalid. Now your answer is right. Khalid and Zaid. Kb will be yes, correct.
Sir, teacher, we don't have to like divide them, right?
No,
To find
no.
the
Because you don't have the values, you just have the angle. If you take tan theta, you'll get the angle simply. You'll get the value of whatever is the division of both the quantities.
okay.
Ka. Samaira, just check once again. Ka. What you have answered is the answer of Kb. Let's discuss it then. See, tan theta is what? Tan theta is the slope of the graph is given by tan theta. And here the slope will be given by V by L because we need V by L. V by L will give us K. And that is what is required to us. So Ka will be given by, you don't need to actually divide these quantities. If the angle is not given, no, then you have to divide V by L. V's value will be given, length's value will also be given. So V by L will be what? Someone has answered Ka Salman. See, Salman and Samaira, both of you. Ka, you are talking about 30 degree. What is tan 30 degree? Ka will be given by tan 30 degree, and Kb, this will be given by tan 60 degree, simply because the angle between B is 60 degree and the angle between A is 30 degrees. So what is tan 30? Tan 30 is simply 1 by root 3, and tan 60 is only root 3. Ka 1 by root 3 and Kb root 3. Yes, this is right. Kb will be root 3. These are two other answers. Now, regarding the sensitivity of the potentiometers, how to calculate the sensitivity of potentiometers? This is also easy. Whichever has the lower value of potential gradient, that has more sensitivity. I'll write it down for you. So whichever potentiometer has a lower value, potentiometer having lower value, that is more sensitive. So in this case, can you tell Ka is also written, Kb is also written. So which is more sensitive, Ka or Kb?
Ka.
Ka. Because Kb value is higher. Kb has a higher value. So we can say sensitivity of A is more because Kb is greater than Ka. When you people will write it down, just text me done in the chat box. So then we'll begin with the applications of potentiometer. Zed, are you asking something? So you have major three applications of potentiometer. First is to measure the EMF. Now measurement of EMF involves the measurement of an unknown cell. This time in the circuit, EMF of the cell was given to you. So EMF of the cell is given to you. That we don't measure because that is already known to us. An unknown EMF is measured. Then there is the second application is comparison of EMF. If you have one EMF, you can easily figure out the second EMF or vice versa. And then measurement of the internal resistance. So let's first do the measurement of EMF. So this is the EMF of the driving cell. We call it as a driving cell, which is known to us. That is already given to us and we know it. That's why we have connected in the circuit. Then the external resistor is also connected. And then this is your potentiometer wire. This is the point AB, which we were calculating, no, VAB, and the external resistance across the potentiometer wire and all this. Now we have another cell whose EMF we have to find out. So let us connect it also. This is the unknown EMF. Capital E is the EMF of the unknown cell, which we have to find out. So potentiometer will help us in finding out. Now how? A galvanometer is connected, and if you people have had your practicals classes, then you must have used potentiometer. You must have seen that a galvanometer is connected with a jockey at its end. And then you hover over this, slide on this potentiometer wire, and you try to find out the null point. Null point is basically, suppose let's say I have moved it and this point I am getting at as the null point. Now basically at the null point you will see the deflection of the galvanometer stops. Otherwise galvanometer was showing some deflections. At the null point it stops. What happens? Basically corresponding to this null point, let me write it down. Corresponding to the null point, current through the galvanometer becomes zero. That's why the galvanometer stops showing any deflection. If any slight current even passes through the galvanometer, then it shows us deflection. But since no current is flowing across the galvanometer, it is not showing us any deflection. So current through the galvanometer, this becomes zero. Now current, this becomes zero. Now what happens to the potential difference? So whatever potential is at the left side, no, that becomes equal to the right side, potential at the right side. So potential is at the right and left side of the null point that you have. So potential at left of galvanometer, this is equal to potential at the right side of the galvanometer. This is basically what happens. This you must have done in your practicals. A small jockey, like this pen, it's a small jockey is there which is connected with the wire and you connect it to the galvanometer. So whichever point you get, you call it as a null point. Let's say L is the separation, small l is the separation from point A to this null point that I am getting. Now how to calculate the EMF? Practical part is done. We have calculated, we have found out the null point. But how to calculate the EMF which is unknown? Basically, what did we study? The principle of galvanometer. Whatever is the potential drop across this is directly proportional to the length of potentiometer wire. So here also, whatever is the EMF of the cell, no, because at that point only it stopped. Had the EMF been different, there would have been a different null point. So whatever is the EMF that we are getting, this is basically directly proportional to the length, and the constant that we use is the potential gradient. So K is what? K is the potential gradient only, which you have been studying. Sometimes potential gradient is directly given to you. You don't need to calculate. Potential gradient, I'm repeating, it is potential per unit length. Now, 2 important points which you should remember. For this to occur means for the cell to be balanced. No, Zaid. Just for your, yes, potentiometer is deleted from your syllabus. This is just brief. We are doing it. We are not going into the details of potentiometer. We'll just do it briefly. All the 3 points we'll see, because major portion of CBC as well as a little portion from your entrances also. This is an important topic. That's why we are discussing it. In short, we are discussing in brief. We are not going into very much details of the whole construction and everything, how to do it. All right. Now, 2 points are there. If EMF is less than or it is equal to the EMF of the driving cell. This is the EMF of the unknown. And this is of the known, which you call it as the driving cell. So in this case, the cell is balanced. If somehow your EMF of the unknown cell, this is greater than EMF of the known cell, then the cell cannot be balanced. All right, so just note down these points, then we'll just like this only we'll study the second point as well, comparison of EMF and measurement of internal resistance formula. Only Wheatstone bridge is now in your syllabus, no? Meter bridge is also deleted, no, Zaid?
Yes.
Meter bridge is also deleted. But meter bridge you people will be able to handle, because potentiometer is, meter bridge is comparatively easy than potentiometer.
Ma'am, could you scroll up a little?
What about others? Done?
Yes, ma'am.
Now, the second point is what? Second was comparison of EMF. Let's discuss that also briefly if you have two EMFs. So, comparison of two EMFs. So, comparison of two EMFs, rest of the things will remain the same. This circuit will be the same. You have one E1 and you have one more cell with you. E2 is also there. And then this also gives a deflection at another point, as I've told you. Potential, that is dependent on the length. So for different lengths, you will be having different values of null point. So one null point you will get here, other null point you will get over here. This is E2. Now how to compare it? Simply, E1 will be equal to KL1. Let's say L1 is this length. And L2 is the length of the second cell. E2 will be equal to what? KL2. Take the ratios. It will be E1 by E2 is equal to L1 by L. That's how we perform the comparison of two EMFs. So note this down also, then we'll discuss the last point as well. Then we can move on to identical cells part. That is important for you. Before that, 3 students I think were there who have appeared for the last test. Khalid, Salman and Maimuna. Maimuna, you had also given, no, the last test?
Yes, teacher.
So are you, rest of the students, are you aware you people have your test today also? Khalid also. But I think most of the students who have given their exams, like Samaira, Hania, you people, Zaid has also, I think, given. Yes, Zaid has also given. So drift velocity and Ohm's law is there. Hardly, I think, 3 questions are there. So you people will be able to manage. Yes or no? Hania, Samaira?
Yes, ma'am.
All right, easy paper is there. You people will be able to deal it. Actually, this was announced in the last class since you people were absent. And what about you, Sneha? Drift velocity and Ohm's law. Are you aware of this topic? Means have you done it?
Yes, ma'am.
So just see if you are comfortable in giving the test, and Sneha, you can also appear for the test. It's a very short test in the class only I'll conduct. So Khalid's paper, this one, no? Yes, Khalid is correct. All right. Salman, one thing in your paper. I remember in your paper, you have just written it in 2 lines. You haven't shown which all capacitors were connected in series and how did you get this? 6 by 7, how are you getting it? You haven't showed it. And then you didn't write which all are then connected in parallel and this way. You just straight away written the answer. All right, so this way you won't be getting marks any. I have given one in board exams, one also won't be given. All right, so just whatever steps you're doing in your yes, just write it. Otherwise, you will lose marks. This is perfect for your entrances because there you have to take on the right MCQ, whatever is your suitable option. But in boards, every step consists of marks. In many times, what happens, your marking scheme is there that this getting this current value will be having half mark, getting the voltage value is half mark, then calculation of resistance has the mark. So, all right, so just keep in mind that. Rest in here also. See, Salman, whenever you are deriving no any term, like Khalid has written in his paper, I think Memuna has also not written this. Always write this. Like you have written C is equal to A epsilon naught by D. So A is what? According to you, A is the area. I know A is the area because I have taught you. But for a third examiner who is checking your paper, nobody knows no what is A. Like D, you have at least specified by showing the separation between the plates. At least show what is sigma. So like you can write consider two parallel plates with sigma as the surface charge density, A is the area of the plates, and D is the separation. All right, Salman, that would allow you not to lose any marks. So rest of the things were fine. Similarly, like this question also, 21E. So I've just deducted half mark because your final answer was definitely correct. So just show like 18E plus, I think 2E plus E, that's how you're getting. And who was there? Memuna is also there. Memuna, rest of the thing like this working. This you have to show. Memuna, same thing. In the derivation, no. Just specify all the terms like this. Rest everything was correct. All right. So it's good that you people appear for test because all the mistakes that will be discussed in the class. So at least you are prevented from committing mistake in the main exam. So if you've written this, just text me done. Then we'll discuss the third point. All right, Salman. All those who have to pray, go for namaz. You people can come in 5 minutes. Forty-eight minutes later. All right, Zach. Then you can just message me whenever you have to leave. No, because after 48 to 50 minutes, whenever is your Maghrib time over there, you can just text me. That time I'll allow you. Hania, okay, Hania. So this was a very short test, though. But okay, fine. So at least do Hania one thing. At least stay, try it. I won't mark you because you were not aware of the test, definitely, because derivation was also there. So that's fine. Just at least take the screenshot of the paper so that you can solve it later. All right, Hania.
Yes, ma'am.
All right, now let's discuss the third part. Third part is the measurement of the internal resistance. Internal resistance of the cell. So this is the last topic of potentiometer. Then we have one more small topic left, and then we'll begin with magnetics. So we'll start with magnetics in the next class only. Chapter number 4 of your NCERT, we'll start in the next class only. Yeah, yes, this can happen that a small portion of your class will be utilized, because today, as you have the test, so I won't be able to complete it. But never mind. Chapter 4 will begin from Monday onwards. Now, measurement of internal resistance of the cell. Internal resistance of the cell of what? Internal resistance of the unknown cell which we are calculating. So this is the whole circuit that we have. Means this is the EMF, this is the external resistor connected. This is the potentiometer wire AB, and this is the unknown cell, capital E. Internal resistance of this cell, of the unknown cell, we have to calculate. So let's say small r is the internal resistance of this cell. And again, galvanometer is connected, you have the jockey connected, and here you get the null point. Let's say C is the null point. So this separation, this is L1. Now, what do we do? In order to find the internal resistance of this cell, you have to have an external resistor of this circuit. This external resistor is of this circuit. We need an external resistor of this circuit as well, no? So that's why we connect an external resistor with a key and connect it. This is the key with an external resistor. Just for your confusion, let me write it. Small r is the internal resistance of the cell. Small r I have taken this time as the internal resistance of the cell. L1, this is the balancing length. Balancing length. When key is open, obviously when key is open, E is the balancing length. So EMF will be equal to what? K L1. If key is closed, let's say L2 is the balancing length. This is key when key is open. If key is closed, then obviously you will get some other EMF. That value will change. So length will change accordingly. This is the balancing length when key is what? Key is closed. All right, so what is the EMF now? Yeah, so what did I write? L2 is the length when key is closed. So EMF of the cell means the whole current. They're actually balancing both the currents. So EMF divided by capital R1 plus small r. R1 is the first external resistor. This is the current multiplied by the resistance. This is equal to what? Potential. This is the potential that I have written. See, this is the current multiplied by the resistance. This is actually V, which is equal to the potential gradient multiplied by the second length that you're getting when key is closed. This is the potential gradient that you're getting. K is equal to V by L. This is the another length. So this is also equal to potential. This is also equal to potential. That's why we have equated. Right hand side is equal to the left hand side. Both of these sides are equal. Now, if you use this equation as well as this equation, let me name this. This is the first equation, and if you use this second equation, if you take the ratio E by R1 plus small r multiplied by R1 is equal to K2, divided by, there it was capital E only, KL. So EMF gets cancelled, KK gets cancelled. What is left? You have R1 divided by R1 plus small r is equal to L2 divided by L1. Now, if you reciprocate it, no need to learn this derivation. I am just deriving because if straight away I'll write down the formula, no, you won't be able to understand each of the terms. So just look at the derivation and have it in your notes. No need to learn it for your examination. So L1 by L2 will be what? L1 by L2 will be reciprocal of this R1 plus small r divided by R1. Now what can we do? This is the final answer actually. We can separate these terms. Like I can write it, no, R1 by R1 plus small r by R1. Both of these are equal. So this cancels and gives 1. So what is left? L1 by L2 is equal to 1 plus R by R1. From here, what do we have to calculate? We actually wanted small r. This is L1 by L2 minus 1 multiplied by R. This is the form. All minutes to note down the small derivation as well. So we have a time of half an hour. We can start with identical sets. Then. So just text me done when you all if you have written. And if you have any doubts on this topic, just ask me. Potentiometer, any topic you are having, or if you are having doubts from the previous class. Yeah, sure, Sneha. It's okay. Just do one thing. As I was suggesting Hani the same, since the test is not very tough. It's when you see the paper, no, you will realize that as soon as you'll see the first question, because this was in the middle of students' exam were going on. That's why I didn't make the paper tough. Paper is very easy. Means easy numericals are there, and one derivation is there. So just stay there, take the screenshot of the paper at least. If you think you're able to do it, then you can attempt the test. Otherwise, you can just inform me and take it as an assignment and do it after the class, after learning the questions. All right, that goes for all of you. All of you means all those who weren't present in the last test and not aware. But I think you people will be able to do. I have conducted the same test in the other batch also, and most of the students have got full marks only. So just look at the paper. If you think you will be able to solve it, you can attempt the test. Otherwise, it's okay. You can take the screenshot, or I'll share the paper with you. You can attempt it as an assignment. All right, Sneha. So done.
Yes.
All right, so let's begin with, see, we have discussed that portion of it. Actually, a small topic from that was what is left when we were discussing cells, no? When we discussed terminal potential difference, EMF of the cell and all those topics. Then we haven't discussed if cells are connected in series or parallel. That's not as tough as the series and parallel combination of the resistors and the capacitor circuit. But we had seen if we have EMF, E and resistor capital R, internal resistance as small r, then what happens? The whole current is given by a certain equation. But what if you have identical cells connected? So in short, I had told you, if series and parallel combination of cells are there, then how to see? For example, this is series combination. All the cells are connected together. So how do you calculate the equivalent EMF? This we have studied in brief earlier as well, but detailing of series and parallel was left. So that we'll see. If you have identicals, they are connected in identical rows, they are connected in identical columns, they are connected in series and parallel. This one small topic is left. It is not a tough topic. Questions come directly from it. And more or less, similar questions have been coming from this topic. So series EMF, this includes, now equivalent EMF will be what? Equivalent EMF, this will be sum of all the EMFs. Just simply keep on adding E1 plus E2 up till, if let's say n number of cells are connected. If n number of cells are connected in a row, then E1 plus E2 plus E3 plus E4 up till En means, if I say n is the number of cell, let's say n is the number of cell that is connected. So if one cell was connected, n was equal to 1, then EMF would have been E. Let's say number of cells was 2, then what would be the EMF? EMF of 2 cells. So n is the number of cells. So E equivalent will ultimately be n multiplied by E, EMF of the cells. Now I am writing E1, E2. Basically, why I'm writing E? E is because, let me just erase E1 and E2. I'm talking about identical cells. Unidentical cells, I have told you. This is similar to unidentical cells only, but difference is that if you have identical cells, then your calculation portion can be reduced. If there is one single cell of EMF E, let's say all these cells are having EMF E and internal resistance is smaller. EMF of 2 cells will be 2E. EMF of 3 cells will be 3E. 4 cells will be 4E. N number of cells are connected. So equivalent EMF will be what? N multiplied by E. So this will be the equivalent EMF. So if n number of cells are connected, let's say n number of identical cells. This is the number of identical cells which is connected. If n number of identical cells is connected, then equivalent EMF is given by NE. Now, current will be given how? Current will be E equivalent divided by R equivalent small r equivalent, because each cell has its different internal resistance plus the external resistor which is connected. So how will we calculate the EMF? E equivalent, simply NE, number of cells multiplied by the EMF of a single cell. How do we calculate the R equivalent? R equivalent is simply calculated by summing all the resistance that you have, R1 plus R2 up till. But since all the EMFs are, all the internal resistance are also equal because we have taken identical cells. So this will be small nr. So what will be the equation? I will be equal to N capital E divided by N small r plus capital R. This is the formula of the current if you have identical cells which are connected in series combination. All right. Now you have 3 cases in this. If external resistor, what if your external resistor, this is greater than your internal resistance? Means first case says, if case 1 says, if your external resistor is greater in comparison to the internal resistance. So just look at one thing. If external resistor is huge, this is very, very bigger than internal resistance. So look at the denominator. What was the denominator? R plus NR? NE by R. Yes, exactly Z, right. So see, it's like capital R is very huge. It's 1000, and NR is a very small quantity. Let's say 1. So if you add 1000 plus 1, that will give you 1000 back. It's like capital R is 1000 and small r is 1. So even if you take NR and add them, what will it be? 1001. So 1001 is almost equal to 1000. Means capital R plus small nr, this is almost equal to capital R. So if your external resistor is greater than your internal resistance, if this is the case, then you can directly substitute it. So your current will be N capital E divided by R. You can replace the whole denominator by just capital R. The reason, because external resistance has a higher value. And if you add a smaller to it, no, there won't be any effect. Just the opposite case. If your internal resistance is greater than your external resistance, means your small r, this is now greater than your capital R. So small r, this is greater than capital R. This is the case now. So now if NR is almost greater than, is very, very greater than capital R. If R is greater than capital R, small r. So what does it mean? Now you are adding a very small quantity like capital R to this huge quantity that is N small r. In the previous case, what happened? In the previous case, capital R was huge. Exactly, Z. Z is right. This will almost be equal to what? This will be almost equal to NR. This time, which is greater? This time, small r is greater. Means this term is having a higher value. So, small capital R is very small in comparison to it. This is NR. Now, what will be the value of current? N capital E was already there in the denominator. Instead of this whole thing, you can just write small n. N gets cancelled. E is equal to capital E divided by R. So these are two formula that you have seen. All right. Case 1 is capital R is greater than small r, and if small r is greater than capital R. Firstly, note down these things, then we'll discuss other things. And if you're having any doubt in between, either text me on the chat box or just unmute yourself and ask. Just remember, this is valid. These formula are only valid for identical cells. Because if these are unidentical cells, identical cells means all the cells have the same EMF and the same internal resistance. If somehow they're unidentical, it means each one will be having different values. So N cannot be applied there. So done. By now, you people must have written it down.
Yes.
All right. So, Zaid, will you give the test? Let me just show you people the question paper. Zaid, I think you will be able to do because you had already prepared for your test, no? You had your exams. See, this is the question paper. Students who were there in the last class will definitely have to give. Others also, please try to give this test. Hania, Sneha, you people can take the screenshot and let me know if you people are leaving. So half an hour is there. 5 minutes for converting into PDF and just upload it on the WhatsApp group. Sneha, are you added on the no? You must not be added on the WhatsApp. No.
Only three questions.
Yes, sir.
Ma'am, three questions only.
Yes, 3 questions only. This is one derivation. This is very easy, 1 marker question. And these consist of 2 marks. This is a 5 marker derivation. So just start your test and make it into a PDF and just submit it on the WhatsApp group. Ahania and Sneha, if you people are not comfortable in giving the test today, since you people were not aware of the test, you can take the screenshot and leave and just inform me before leaving once.
Ma'am, we also have to do this test, right?
Yes, Khalid?
We also have to write this test, right?
Yes, this is your test, not an assignment.
Oh,
Okay, Sumaira. Okay. Just take the screenshot and do it as an assignment at least for those people. Sumaira, Hania. Khalid, Salman, and Memuna. I've informed you people you were there. Okay, Sneha. All right. Remember how much time will it take you? Do you have any idea? If you send it through the WhatsApp. Or okay, send me in the chat box. Fine, send me in the chat box.
Okay, teacher, I'll send in chat box.
Okay, Khalid, you can leave.
Thank you, teacher. Allah Hafiz.
Okay, Allah Hafiz. Memuna, if you're having issues, I've sent you my email ID. You can mail it. What about you both, Salman and Zaid? What's your progress? Which question?
Almost finished last one.
And Zaid?
Ma'am, question number 2, second part.
All right, all right.
Teacher, I sent in the chat box. Did you receive?
Yes, Memuna, fine. And you can leave.
Okay, thank you, teacher.